All right, last lesson here in Unit 5 is writing linear inequalities given a graph. Here we can use slope-intercept form or point-slope form. It depends on the graph. A couple key ideas that you're looking for is the slope positive or negative. Can you identify two exact points to draw your slope triangle? Do you know the y-intercept? If you do not, you're going to have to use one of those points. Now, because it's an inequality, we add these two options here just to make sure that we're looking for all the right things, okay? And those options are, is it dashed or solid? And then is it shaded above or below? And that's going to help us determine if it's a greater than or a less than. All right, so let's take a look at an example here. Right, the linear inequality for the graph below. So when we look at this graph, the first couple things that we should notice as we're taking a look here is that this is a dashed line. The other piece that I would notice is that it's shaded above, okay, not below. This is below. So this tells me it's going to be a greater than. All right, y is going to be greater than. No equal to because it's dashed. All right, so that's half the battle there. All right, the next piece would be to calculate whatever that slope might be on this picture. So if I can identify two exact points, I can count the blocks, okay. Up 4 over 2 is what I'm looking at. So my m would be 4 over 2, which is 2. Now I look and see, do I see the y-intercept? Do I know what the y-intercept is? And when I look at this graph, I do. It's exactly -4. So that means I can write this in slope-intercept form. So when I put all of these pieces together, I'm going to have y is greater than 2x minus 4. Okay? -4 was the y-intercept. 2 was the slope that I found. Greater than because it's dashed, and because it's above. Let's take a look at another example. Write the linear inequality for the graph below. So again, go through here and just kind of start to determine some of the pieces of this. It's a solid line, so it's going to have an equal to. All right. If this is above and this is below, it's now shaded below. So it's going to be less than or equal to. All right. Find two exact coordinates. It looks like there's one here, and it looks like there's one here. All right. I have a down 2 and an over 3. So my m is -2 over 3, which makes sense because my line's going down. And I can identify this y-intercept. It is exactly 1. So letting you off the hook here. Slope-intercept form is the best. When I put all of that together, I'm going to have y less than or equal to now -2/3 x, that's my slope, plus 1, that's my y-intercept. Y-intercept, growth, solid, below. And last one here is a challenging one. We can start the same way in that we know that this is dashed. Okay. And we see that it's shaded below. The difference here is we don't see the y-axis. This graph starts at 2,000. All right, so we don't see the y-axis, but I gave you points here, so I can still do a slope triangle through these 2 points. All right, now I can't count blocks though because my units aren't in ones. So if I go from 900 here down to 700 here for y, that means I went down 200, so -200. If I go from 2200x here to 2600x here, I run 400. So my m is -200 over 400, which reduces to -1/2. So I have my m. I do not have my y-intercept. Okay, so I'm going to have to use point slope. So I'll choose this point. I'm going to just write an equation first and then worry about this symbol. So my equation would say y minus 900 equals -1/2 x minus 2200. Okay, now I know it's not equals because it's an inequality, it's shaded below. So the next step here would be to get the y by itself, and then I can just plug in my inequality symbol that I already know. So to do that, I would add 900. So y, okay, and then negative 1/2 x minus 2200 plus 900. I don't have to do anything there. I can just put plus 900. Now, since y is by itself, I can say y has to be less. I can only do that when the y is by itself. So here y is less than that. If you want to simplify that further, you could, but you don't have to.